But welcome back after lunch. Always a tricky slot now. Everyone's full of, carbohydrates. Got to try and keep everyone awake and so forth. Quite a tricky time. But I'll try and keep... thank you. That's awesome. Thank you. I'll try and keep it entertaining. So we're going to be looking at continuous delivery with containers. And I've put it as the good, the bad, and the ugly over my kind of sharing my experiences over the last 5 or so years, I guess, working with containers. Now, I think ever since the emergence of Docker, we've kind of been sold a certain vision, a certain kind of dream, yeah? And what it is, it's pretty much take your existing applications, put them in containers, perhaps carve them up into microservices, kind of functions, all that kind of thing. This is the dream we're sold. Take your applications, old or new, put them in a container, ship it, you're good to go. The reality is, many of us have got applications, particularly legacy or money-making, that are a bit of a tire fire, yeah? And I've certainly designed my fair share of tire fires as well. And what happens when you put them into a container is you literally get tire fire in a container. Yeah, this is not a good look. And if you see the firefighters down here, this is what we commonly refer to as DevOps in our industry, yeah? This is how I make my money as a consultant in the UK, Germany, and the US as well. So continuous delivery is a massive topic. We'll do a very sort of brief, overview of what it is in a moment. This talk is very much a technical talk. I do organizational ones and technical as well. This is a technical one. We're not going to be focusing on the stuff that is super, super important, like the culture, like the organizational stuff. I might shout out Mike a few times here. Mike did a great talk about Bull's journey, and culture and organization and communication was a key part of that journey. So I'm not going to talk a lot about that today, but it is really critical. This talk also assumes you've gone all in on containers. Now, I'm not saying that's right for you. I don't know your context. I don't know your organization. I've done a lot of work with Cloud Foundry and a lot of work with Lambda, Amazon Lambda, and I think they're super cool tech. But a lot of what we're going to be talking about today is focused on containers, as in packaging stuff up, putting it in Docker, putting it in LXD or that kind of container system. I'm not going to do any live coding because I'm kind of rubbish at it, but I will talk through some code, for example, some code examples, some configuration examples. And the book on the top is free. You can get that one on O'Reilly, thanks to Nginx. Nginx has sponsored that one. It's generally talking about some of the stuff I'm going to be discussing today, but more technical detail. There's a GitHub repo, lots of code, lots of examples in there. It is Java focused because I mainly am a Java developer. Bit of Go, bit of JavaScript as well. And I'm working on a full book which will be out hopefully, I think later in the year sometime when I finish it. Writing a book is awesome, but it's very hard. The kind of takeaways I'd like to get you thinking about today are these 3 things. That when you're deploying with a container, this now becomes your single binary, the thing that you should package and push down a build pipeline as early as possible in the cycle. I see some people having multiple versions of an image pushed down their pipeline. When it passes one stage of testing, they take it out, put it in another image, these kind of things. Now the image is a single binary that goes down through the pipeline. Adding metadata is super, super important. Provenance, sign-off, security issues. People have sort of bumped into Equifax and other kind of hacks going on. A lot of it is not knowing what people have in production. And metadata is super critical to know what code you have in production and what vulnerabilities you're potentially exposed to. And kind of this thing is we must validate constraints that the container technology puts onto us. Every new technology, be it even back in the days doing Corba, doing Java EE stuff, every technology brings with its own set of baggage, its own benefits, its own drawbacks. And I'm going to say that, particularly in relation to security and performance, containers can actually quite alter the platform you're running on, and we need to bear that in mind. This is me. I'm at Daniel Bryant on most places. Love getting involved in the Twitters, GitHub, LinkedIn, Medium. You'll find me there. I work as an independent tech consultant. I'm also helping a company based out of Boston called DataWire, and they're looking at tooling around the Kubernetes developer workflow space. So I might mention a couple of tools, but no sales pitches today. I do strongly believe, even though my background is very much a development background, I've got into ops over the last few years as well, but I do a lot of business and a lot of leadership stuff, because I think that is super, super important. As I've gotten more opportunities for leadership roles, I've realized my people skills need to constantly improve. I'm sure you've guessed it, but I'm a native English speaker as well, and I do tend to talk quite fast sometimes. So if I go too fast, feel free to put up your hand. The joke when I did that in a conference in Germany is my next sentence, everyone put up their hand. But this talk is also on, it's being recorded, and it's on YouTube, so you can watch it back at half speed later if you want as well. It's all good. So Continuous Delivery 101, I saw a lot of nods when I mentioned continuous delivery, but is everyone familiar with continuous delivery? We're all pretty happy with that. Fantastic book. It's maybe 10 years old now, or not quite, but it's quite old. Some of the tech in there isn't quite so up to date, but it's a fantastic read. I strongly encourage you to look at this as kind of the foundations of a lot of what we're talking about today. It's all about producing valuable and robust software in short cycles and optimizing for feedback and learning. These are the key things, yeah? It is not necessarily continuous deployment. You should be ready to deliver the application at any given time, but you don't have to automatically deploy it. Some clients I work with get super nervous with the idea of, from commit to production, all automated. They like the human touch sort of involved. And I'm cool with that. That works for me as well. The continuous deployment is nice if you can get it working and if your organization likes it, but continuous delivery doesn't mean necessarily automated deployment. What a lot of us are aiming for these days with the current market is velocity and stability. These are the key things, yeah. Think about, this doesn't necessarily apply to if you're building software to nuclear reactors. Maybe you don't want to go fast with nuclear reactors, but you sure want to be stable. But if you're building something like a Netflix or a Spotify, you also want the speed. Your competitive advantage is to go faster than your competitor, yeah. And I think Steve Smith, a friend of mine from London, said it best. Continuous delivery is achieved when stability and speed can satisfy business demand. And that's in your context. Yeah? My business context is different from one of yours. I'm sure a lot of us have seen discontinuous delivery. And this occurs when we get that mismatch. The business wants us to go faster, or we get breached like Equifax, or we fall over in terms of performance, things like that. Yeah? And I'm going to point at Equifax a little bit today. I think it's obviously bad what they've done, but let's be truthful, they were the ones that got caught. I'm sure many companies have got security issues. Yeah, many teams I work with, when I go in, they don't have security checking. So we'll look at that a bit today. I think it's critical. Hopefully not controversial. Creation of a build pipeline is mandatory for continuous delivery. Yeah, and a typical build pipeline looks like this. This is a Java-themed pipeline, but I'm coding away on my laptop, working within a team. I'm then pushing my code to GitHub. I'm probably building using Jenkins or Circle CI. Might be doing some code quality analysis, some static code analysis, shipping it to QA, doing some tests. If we're happy, ship it to staging. If we're happy, push it to prod. Now, continuous delivery definitely does not end there. Many people think it does. But it's the loop, it's the feedback that's critical. We use the pipeline to ensure what we're pushing to production is stable. We use the loop to make sure we can go faster. We can outcompete our competition. And we're looking for, can we prove our business hypothesis? How do we improve the architecture? How do we improve the ops stuff? Containers, I'm sure by now everyone's pretty familiar with Docker and containers and so forth. It is, as a Java developer, it made total sense to me. I've been used to dealing with VMs, like low-level OpenStack stuff, and I was used to dealing with application virtualization in the JVM, or the CLR, if you're a .NET person. And Docker and the likes of the Linux containers are in the middle. They're above infrastructure virtualization, but they're below application virtualization. The key thing I want to say is whatever you're deploying, you now need to put it into a container image and ship that. What you don't want to do is do all your build, all your tests, and at the very last moment, put it in a container. Yeah? You want to test the container all the way through your pipeline because the container changes some of the properties of your code, of your application. Yeah? How does it alter this pipeline? Fundamentally, I think in 4 places. Now I'm developing locally. I might want to be developing in a container, or at least doing happy path tests. when I'm building stuff now, I'm not building maybe, or I probably am going to build a language artifact, like a jar or a .NET Nougat, but I'm going to be putting that thing in an image, in a container image. I'm clearly going to be running and orchestrating my tests slightly differently now, because I'm testing container packaged technology. And my deployment fabric is probably no longer VMs or OpenStack. It's probably, you know, Kubernetes, ECS, or Mesos, something like that, yeah. I'm not going to talk much about this, but microservices obviously multiply the challenges. You have more than one pipeline. You can kind of do gated deployment, you can see here, or you can go for the aim really is independent deployment. But you've got to be careful, of course, of different services clashing. APIs changing, accidentally breaking someone else's code, message payloads changing, accidentally breaking someone else's service. I've talked about this in I put a link there in a VJUG, Virtual Java User Group talk I did last year sometime. So if you want to know more about the kind of consumer-driven contracts, virtualization, all that kind of good stuff, mocking, stubbing, check out that talk. But this one's going to be focused more on pipelines for containers. So let's dive into the first step. So how does it change my local development environment? Well, like anything you're doing, you should make your development environment as production-like as possible. And if you can't, you may need to move your development environment into the target environment. You may need to move say if you're doing Lambda or serverless, you may actually need to develop in the cloud. Now, Amazon, AWS are doing Cloud9 and a lot of platforms like that, so we're seeing that pop up. But to be honest, when I'm developing, say, Java applications that are going to be container packaged, my workflow locally doesn't alter massively. I'm coding away. Usually I package my artifact and run my tests on that locally. So I'm just using Spring Boot, auto reload, doing my thing. I maybe virtualize some of the other microservices I'm dependent on. I maybe run embedded data stores, embedded queues, if I'm dependent on them. If you're familiar with Amazon, there's an awesome tool called Local Stack by Atlassian, and Local Stack allows you to virtualize all the AWS infrastructure on your laptop, which is kind of cool. Well, not all of it, but a lot of it. Whatever you do when you're building locally is do run your tests on the container packaged artifact. Yeah, do run the happy path tests. This will show up some obvious stuff where maybe you've specified memory too tight on the container or there's some other issue. Yeah. And a big one, hopefully this is fairly obvious, but I do see it quite a bit in my consultancy, is whatever OS you are using in production, make sure you use that in dev. Yeah, because there is an OS, an operating system, going into the container image. And I've seen a bunch of companies that are running, say, CentOS in production for various security reasons, SE Linux, that kind of stuff. And then locally, they're using Ubuntu. And there is subtle and not so subtle differences between the Linux distros, yeah, particularly around crypto and things like that. So whatever you need to have in production, you should be doing locally as well. It gets a point, and I don't know if anyone's bumped into Cindy Sridharan's work, Copy Construct on Twitter and Medium. She's an awesome lady, great thinking. But there comes a point where when you're working with a microservice system or a system with a lot of legacy components where you cannot physically spin everything up on your local machine, yeah? And therefore you kind of have to work remotely. Now, I talked about this in an article, I think 2 or 3 years ago, when I was working with a company called OpenCredo. Excuse me. And we talked about sort of different patterns for working with microservices. And one of the patterns, which Cindy talked about recently as well, is this notion of environment leasing. I was working on a project with a company called Not on the High Street, kind of a UK version of Etsy, a marketplace. And we had the ability to spin up on-demand QA environments. Yeah, we were using Mesos at the time, and we were using, say, Terraform and Ansible and AWS. And any developer or any QA on demand could spin up a QA environment and deploy the services they wanted with the data stores they wanted and do their testing. This was a very powerful pattern. But we couldn't work very well locally with the remote environments. We did some proxying and we sort of halfway got there. But there is some tools now, and this is a kind of shameless plug because it's a DataWire tool, but it's an open source tool, very useful, telepresence, there's K-Sync, there's a couple of other ones as well. And they effectively allow you to proxy into a remote Kubernetes cluster in this example. So I'm running stuff locally, I'm developing locally, but I can interact with all my cluster as if my laptop was in the cluster. Yeah, so I can dig namespaces, I can do auto reload and watch what's happening, say, at the front end. This is a useful pattern combined with service virtualization for virtualizing really hard to run legacy components. These two patterns have saved me a lot of times where I couldn't physically get all the services on my local machine. Yeah, but regardless of whether you're doing this development locally or in the cloud, say, one thing I learned is that Dockerfile content, or your container of choice, is super important. Yeah? Not all developers, myself included a couple of years ago, are operationally aware. Yeah? They're really good at writing code, say, but they don't really care about Linux. They don't really care about ops. But there's a bunch of challenges when you are deploying something in a container image. I've mentioned OS choice already. There's config, there's secrets. There's how do you put the build artifacts in the image itself, and how do you expose ports. I'm not going to name any names, but some of the companies I've looked at, it was a bit of a horror show in production. Full fat Ubuntu VM, massive attack surface, full fat JDK running in there, and ports open. Yeah, and like first thing I did was strip it down, real lightweight Ubuntu or Debian, say, close all the ports down. And run a JRE as opposed to a JDK in production, things like that. But these are not trivial examples. If you are, and I kind of think most people that come to conferences, you're trying to learn more, so you're probably aware of these things. But a lot of people that unfortunately can't come to conferences for whatever reason, particularly developers, they tend to be less operationally aware. So they don't know about the choices of these things. Golang, shipping stuff in Scratch images, or Python. Do you still need virtual env if you've got a container giving isolation? Bottom line is talk to the sysadmin team in your company. Yeah, and if they're not very friendly, you've got to work really hard at this stuff. Yeah. I identify mainly as a developer, so that kind of I think this is really true though. If I'm doing a new migration project with a company, one of the first things I do is get InfoSec, get the ops team in on day one, because if they're not consulted, they will push back a lot later in the project. And not only that, often their insight is super, super valuable. So get InfoSec involved early on. They may be scared about containers, but you need to work together to get over those things. One sort of bad, ugly thing I see is people having different test and prod containers. So they do all their tests on one container, and then they repackage their artifact in a production container, but do no tests on that container. Yeah. So I don't like this. This is the kind of, you create this full fat version, then you make it lightweight into production. Really, you should make it lightweight throughout the build pipeline. Whatever you're putting into production should be what you're running your tests on in the build pipeline. The main reason is easy to see drift. Yeah, you see, your dev kind of test cluster containers differ some subtle way, and then that subtle way becomes quite big until what you're putting in production is not the same as what you're putting in your tests. I like the use of what's called the test sidecar. So I have my lightweight container that's going into production, and I create another container image with all of my test tools. Maybe it's got some pre-canned data running in H2 for an embedded kind of MySQL, something like that. And there's a great proposal called by Lexi, on test proposal, and they talk about this kind of pattern and a sort of proposal for extending the Docker config language. Don't think it went anywhere, to be honest, that proposal, but it's a really nice pattern for how to properly test the image that's going to end up in production without needing to chuck all your test tools in that image. You can use a sidecar. Quite nice. We're seeing a lot of sidecar stuff these days with things like Istio and all that kind of stuff. This is a slightly different sidecar, but the pattern is the same. Yeah. There's a reference for you. One thing people haven't bumped into, it's surprising. It was out, I think, a year ago, but you can do Docker multi-stage builds. So there's two froms here. There's a from for building, this is Golang, and a from for deployment. This, for me, kind of is still okay. Although I'm deploying into a different container, it's all packaged in one config file, and it's all in one place so I can understand what's going on. And I still run my tests on the image that's being pushed to production. But this is quite a nice pattern. You can sneak a few tests in up in the builder from, but you really want to do your main tests on the resulting image, the resulting artifact. That kind of wraps up the build. Let's look a little bit now at, so that wraps up developing locally, I should say, sorry. Let's look now at sort of the building. I'm not going to go into too many details because it tends to be quite language specific. If you're doing Java, you might use Jenkins, for example. I've got a love-hate relationship with Jenkins, but I'm sure many of us have, yeah. But it's the least worst option in many times, and the CloudBees plugin is really good. There's a new thing called Jenkins X that's released a couple of weeks ago, and James Strachan, who's behind Fabricate, is working on a Kubernetes native Jenkins, and that one does look quite interesting. So as much as I do to make fun of Jenkins, it's actually a cool tool, and it is evolving with the times as well. You can look in the book if you want to know more about that stuff, but what I'd like to say today is metadata is really important. Yeah, you need, particularly when you're operating at sort of anything other than a startup scale, you really need to understand what you have in production. And as we're getting microservices and functions and all these things, we're dividing our application up, but we're losing control of knowing what is going where. Yeah, it's even a bit of a thought experiment. Do you honestly know what version, say if you're running an application in production, do you honestly know what version of an OS you're running on? Do you know, could you tell me by running a couple of commands all of the latest patches on your OS? Could you tell me, have you got all the latest dependencies included in your container? You know, if you can't do that, I would perhaps go back to your office and at least raise a ticket for, we ought to think about this. If say something massive comes out tomorrow, Heartbleed 2 or something else, you need to very quickly understand what you've got in production and create a plan to fix it. So this stuff is really, really important. Things like build versions, metadata, whether it's been quality controlled, all things like that. Running through a few sort of examples is, I'm sure many of you might have even been bitten by this. The latest tag is kind of, there's a great blog, I'm not going to go into it, I always get it subtly wrong, but the latest tag has got a certain sort of semantics around it. I would recommend not using the latest tag in Docker. Instead, use semver or semantic versioning, where you have that major, minor patch thing. Yeah, then it's much more obvious what you're running in production. 2.4.1 rather than latest, which we think is 2.4.1, but we maybe can't be sure. The latest tag is effectively the last build that ran without a version specified. And I've seen people trip themselves up by running builds and pushing them without using the pipeline, things like that, so be very careful with that kind of stuff. In terms of adding metadata, Docker labels is a nice way to do it. You can add the actual data to the I've got an example here, yeah, to the image. You've got your Dockerfile here. You want to namespace your labels, so org.codemotion, that kind of thing. And you want to put all your data, builds, the data, who triggered these builds, these kind of things. And this is done at build time. Adding the label into the Docker file. You can then include your Docker file actually into the Docker image. There's a little trick to do that as well. But there's a nice make file that I think it's Rob from Microscaling Systems created, where it does a lot of this stuff automatically for you. Excuse me. You can basically, it takes a lot of info from the Git data, takes a lot of info from your local build, the user, the time, and it then automatically bundles all that metadata into the labels. This is quite powerful, quite nice. You can't do this thing very well at runtime, so you can't really spin up a container, do some tests, and put some more labels on, because any label you add at runtime is ephemeral. It gets deleted as soon as the container is shut down. You can Docker commit the label, but it kind of defeats the purpose of the single binary. Yeah. So there's talk about having a sort of an update proposal. I don't think that's going anywhere. Most of us now put the metadata associated with an image into a registry, something like JFrog or Nexus. This is a PG conference. The frog is hugging the whale. As simple as that, yeah? There's it's like slightly dodgy kind of looking graphics there. But I often store my image and my metadata as close as possible together, but in a registry, yeah? And I don't know if anyone's bumped into Graphius. It's a very cool project. I think Google and a few other people, I'll be honest, most of the stuff you see me talking about, I've used in production. This I haven't yet, but I'm very keen. Grapheus is a sort of open standard based around metadata. I'm thinking it's probably going to go into the CNCF, if anyone's bumped into the Cloud Native Computing Foundation. And there's another tool called Critis, which Spotify have talked about, how you can basically apply governance to cloud native systems, particularly Docker containers and Kubernetes. Yeah. And as a kind of example, this is what Google were pitching. You'll recognize the kind of pipeline going across the top here, and then ultimately you're deploying, say, your containers from the pipeline into Kubernetes. This is Google, so it's GKE, for example. But you're recording all your metadata in Grapheus, how do you pronounce it? Grapheus. And you can basically, there's some plugins that you can put into any version of Kubernetes, but it's linked into GKE, and it will only deploy based on a series of criteria. Docker have got this already, Docker Enterprise as well. They use Notary and a bunch of other stuff to do this. But with Grapheus, you can basically specify, I think they're called attestations. And you can, as something passes a security check, you can basically cryptographically sign the image. Yeah? This has passed black duck scanning. This has passed penetration testing. And you can basically say only stuff in production, will only deploy stuff in using Kubernetes that has cryptographic signatures for all the stages of the pipeline. We built it, we've load tested it, we've security tested it, these kind of things. This is going to be a standard way of doing things, and I think Grapheus is a great tool to kind of drive this. And it's Google sponsored, which is generally a good sign, and I do think it's going to go into the CNCF as well. Excuse me 1 second. You can do a bunch of other stuff. They've got, I think, 5 different kind of metadata formats. So you can describe sort of security properties of an image, like of a container image, or of a, say, a function as a service type package. There's also a standard for package vulnerabilities. So if you're using a commercial tool like Black Duck to do security scanning, or like Black Duck, I think it's JFrog, many people in the industry have signed up to this standard. This is the way they're going to communicate that, this container image has these vulnerabilities. And the vulnerabilities could be OS-based, or they could be even, say, dependencies or your code, for example. But this is the way we can build tooling around a standard and build kind of automation around a standard, which is quite nice. So moving on to some of the QA stuff now. So the book talks a lot about how I've used Docker Compose for spinning up kind of groups of containers. Maybe not the whole application, but spinning up groups of containers, doing things like component testing, integration testing. So I'm not going to cover that too much today. I'm mainly going to stick on non-functional requirements or system quality attributes. And in particular, I think it's really important that as we're building applications, we think about things like architecture, load testing, and also security. And I'm mainly today going to, just because of time, we've got 40 minutes, I'm mainly going to focus on security, because I think this is the area that is often neglected in companies I work with as well. So there are a couple of security references. If you're looking at scanning container images, we'll talk about it a bit more in a second. There's a really nice open source tool called Claire by CoreOS, really, really worth checking out. And there's a gent called Aaron Gratifiore, who did a fantastic talk, I think it was 2 years ago now, at DockerCon over in the US. And even though it's 2 years old, it's a really good, I wrote it up on InfoQ. He talks faster than me, yeah, and it was an hour talk. And the gold in that talk was amazing. He's written a CIS report on container vulnerabilities. Talks about capabilities, syscalls, stuff that goes over my head sometimes. But it really helped me understand and build a mental model around how containers change the threat landscape. How we're packaging things in containers, maybe accidentally leaving open the root user or something, and many more things. So these are my 2 references I would recommend you have a look at. But dialing it back a second, I hope many of you in the audience are using vulnerability scanners. Yeah, we sort of follow it logically through. This is an example I've got in my book. In the Java world, I often use find sec bugs. It's a plugin for static scanning. It looks at your code and checks for patterns of known vulnerabilities. Classic one I see is often, I put this in my book, is people in Java will shell out to the underlying operating system and leave themselves open for basically an injection attack, much like a SQL injection attack, yeah? So find bugs can parse your code as part of a build pipeline and spot known patterns where we all just do daft stuff sometimes. I certainly do, yeah? And it will stop. You can fail the build if there's a vulnerability that we have written in our code. Next level is dependency scanning. The more and more I'm embracing, say, serverless frameworks, the less code I'm writing, but the more dependencies I'm bringing in. Yeah, if anyone, particularly JavaScript, love-hate relationship there probably as well. But I write like 10 lines of Lambda code, but I bring in like 5 megs of of dependencies. It's a lot of dependencies. Yeah. So OWASP, got to shout out OWASP, fantastic open consortium that specialize in helping us as developers, as engineers, understand the threat landscape, and they've got a couple of great language-agnostic tools. So this is the OWASP dependency scanner. It works on Java, I think .NET, Python, there's a couple other things as well. But it basically will look at your dependencies, get all the version numbers, and compare them with the National Vulnerability Database. And of course, when we say National Vulnerability Database, it's a US thing, hence the national there. But so, for example, in Java, it's super simple. It's like 10 lines of Maven, or even less Gradle. And what that plugin does is when I run a build, it says, oh, you're using version 1.10 of Log4j, a logging library. Phones up the National Vulnerability Database. It's all cached and stuff. Basically, it says, do we know if version 1.10 has any CVEs, has any common vulnerabilities and exploits? And if it does, it comes back and says, yes, this is a vulnerable version of the library. It's up to us what we do with it from then. We can upgrade the library or throw it away or change it or whatever, but we need to know, first off, what is going on. This is an example of a Spring Boot app. I think it was a 6-month-old Spring Boot app. And I added my plugin there, I ran, and it came back with 5 critical vulnerabilities. Yeah, that if I hadn't have run my pipeline every day, I wouldn't have known that these vulnerabilities had crept up. So we need to, you need to run your build pipeline every day, even if new code is not being committed, even if new config is not being committed. Run your pipeline, make sure you know your dependencies are secure, basically, yeah. And you get a fancy nice report you can put on your Jenkins dashboard of showing the vulnerabilities and the severity impact, things like that. Very cool. But what we're here for today is more the container stuff, and we're now verifying our code. We're verifying our dependencies, but we're putting those things in a package into a container. And the container contains an OS with associated libraries, OpenSSL, maybe Vim, Emacs, or something like that, yeah. There is an awesome open source tool called Claire that scans the static scanning of container images. It looks for known vulnerabilities in packages and OS config. Claire is what powers CoreOS's Quay, or Key, depending on how you pronounce it. But Key is the registry that powers Tectonic, which is their version of kind of Kubernetes. But you can run this locally. It's GitHub, it's open source. It was a real pain to get up and running, to be honest, when I used to use it about a year ago. I was at a talk in London, and Armin, awesome gent, Armin came up to me at the end of the talk and said, hey, Daniel, no need to struggle with all this all this Go packaging. If anyone's worked with Go, the dependency management is a bit fiddly at times. But he said, no need to worry about all that kind of stuff. I've actually put all you need for Claire scanning in a Docker image itself. Yeah. So I've got to shout out Armin. It's called Claire Scanner. The link's there. You can basically now spin up his image. There is a little bit of Go magic you have to do, but he's written it all down. You can spin up a Claire Scanner image and use that image to scan your images for heartbleed, for known issues, that kind of stuff, yeah. Super useful stuff. I did this, I'm mainly a Java person, so I pulled down, this is November, I think, I pulled down the latest version of OpenJDK. This is the sort of community version. I think it might be Debian under the hood, I can't exactly remember, but Debian OS, and it's very simple, it's just got the JRE, actually, this one. And this is the number of vulnerabilities found. And if you can't see because it's a bit small, there's probably like 100 there, yeah? Known CVEs in this image, yeah? And this is the latest when I pulled it down. And some of these things are pretty esoteric. You will never going to see them in production because if you're running a firewall, it's irrelevant. But we as developers, we as engineers need to understand these things, communicate to our leadership, or if we're leaders, we need to make a decision. How much time and energy do we need to put into figuring out whether we're affected by these things? Yes, it seems like a big burden, but we are seeing with the likes of the VW trial, developers are going to jail for bad things, yeah? So as professionals, I do believe we need to at least get awareness of these things. Otherwise, we could be criminally negligent, yeah? Sounds a bit dramatic, but I think we're on the verge of heavy regulation coming into our industry. The likes of the Cambridge Analytica stuff, I'm sure you're all seeing in the news. We are a very unregulated industry at the moment. So I think these things, we as leaders in the tech scene need to get on this stuff before the government kind of forces it on us, yeah? I think at least. One pushback I get with all these security scanning and performance testing and architecture testing is we really need to do a lot of these things at the last responsible moment. People say to us, oh, I'm agile. This company's agile. We do everything at the last responsible moment. That basically means, if you're building functionality, this is a powerful idea. You don't make a decision until you know as much as you can, and then if you don't make it, it's irresponsible. So you get as much information as you can, you make a decision at the last responsible moment. If you don't make a decision there, one is made for you. For functionality, this is really good because you learn as much as you can. But the thing is, the last responsible moment, bit of a news flash for these security things, yeah? Sometimes it's up front. Sometimes we need to think about how big is our system going to be? How many users are we targeting? What kind of threat landscape is there? Are we building a government system? Is it going to be open for attack all the time, which a lot of them are? And modern architectures, microservices, just add more components. Modern platforms mean we as engineers need to understand more things. So it makes it harder. And the danger is, this meme I really like, it's I can fix it right or I can fix it fast. This is what fast looks like, yeah? And I've seen a few companies do this. We call it broken windows, where, we'll turn off the security scanner because we've got a tight deadline. That security scanner never goes back on, yeah? I've been in companies like that, so I'm a bit guilty maybe, but we need to think about these kind of things, yeah? Really quite critical. Right, so I'm dead close to time now. So what I would say is that things I haven't really gone to in much depth but are worth checking out, and I'll put these slides online, is if you're using, say, Docker and Java, the container impacts the runtime. Pre-Java 9, the JRE, the Java runtime, cannot detect the number of hosts properly in the operating system. And it bases a lot of garbage collection and other calculations on incorrect results. It looks at the whole box and says, oh, I've got 64 cores, whereas in reality, the container may only give you 4. Bunch of stuff around memory. Entropy is super important. Yeah, so the container sometimes, if you're running lots of containers with lots of OSs, it reduces the entropy generation. And entropy is the randomness, moving the mouse, banging the keyboard. That entropy is used for crypto. Yeah, and if you use dev random on Linux is blocking. If you have low entropy or no entropy, your applications will freeze when they try to do a crypto operation, such as a session login or a token kind of call. I'm not talking about deployment much. There's a fantastic thing. If you're going to be deploying complex applications in containers, you probably want to put them in use something like Draft or Helm, like a richer packaging system. Fantastic article there. Talks more about a couple of options for building Docker containers in Kubernetes clusters and out of clusters. Great article. And I haven't really talked much about observability, but a couple of links for you there for getting observability and feeding that feedback pipeline up. Right, so I'll just quickly skip ahead now. And one final thing, using containers doesn't get rid of the need for architecture practices, yeah? And I've seen this a few times. We crammed this monolith into a container and called it a microservice. This is not a good look, yeah? I'm sure we're all tempted. Think about those things. Don't forget your fundamentals, coupling, cohesion, separation of concerns, all that good stuff. But this is kind of what I've talked about today. Continuous delivery, I think it's more and more important. Think about your image being the single package. Understand and assert security and non-functional properties in the pipeline. And the tooling's all there now. We as developers, as engineers, have just got to figure out all this tooling and plug it all together to build a comprehensive pipeline. On that note, I shall say thanks for listening. Bunch of other recommended reading as well. If you're interested in, I love books, so a bunch of other books for you there as well. I don't think we've got time for questions. I'm kicking around the conference the next hour or so. Unfortunately, I've got to leave back for the UK at 4 o'clock, but you can catch me in the next hour if you do want to chat to me. And I'm on Twitter. I'm on email. Twitter is the best way to get in contact if you do want to ask any questions. Right.